everybody, and welcome to this first tutorial of the series. Here we will review some of the basic concepts in regard to the network traffic. It is very important for you to understand some of the basic terms so that the information that we will later gather with Wireshark can be understood. Keynote here: if you feel that you are already familiar with basic concepts such as IP addresses, MAC addresses, ports, protocols, and so on, you can go ahead and skip to the installation and setup tutorial. Okay then. Most likely, at some point of time, you have heard the term IP address, but you never really understood what it actually is or what it is used for. IP addresses, in essence, were designed in order to make it possible for devices to be able to communicate with one another within local networks or in general over the internet. And that is the primary purpose of an IP address. Aside from that, it can also be used to pinpoint the exact physical location of any device that is using it. Basically, you can compare it to a mailing address. It is unique and used for sending packets. Computers and other devices work on similar principles as your local mail. You specify recipient and sender address, take the letter or packet to the mail office, and send it. Computers pretty much do the same thing, except instead of a street address, they use an IP address. Internet Protocol, or IP as it is more commonly known, is just a set of predefined rules that dictate the terms under which communication shall be conducted. For example, it enables you to browse the web by enabling you to contact a series of servers who also operate on the same protocol. IP addresses consist of 4 numbers, and each of the 4 numbers can go from 0 to 255. The limiter used to separate them is a dot. Here's an example of how it looks like. Now I have my terminal here set up, and just gonna type ifconfig. That's gonna list out all of my interfaces. So I have a loopback, which is LO, the first one. I have P8P1, which is my Ethernet connection. I have VRBR1, that's my virtual machine thing. That's for the virtual machines. The one that we're going to be focusing now is VLP2S0, which is my wireless interface. So I'm just going to type just going to clear the screen first, and I'm going to type ifconfig VLP2S0. No, ifconfig VLP2S0. There we go. So it gives you a bunch of information here. And what is what? So we're not interested in most of it, as most of it is of really no use to us at the moment. The part that we are interested in is the INET, so the address, the IP address of the interface. You have 192.168.1.2. So this is basically how it looks like. So 192.168.1.1.2. So each one of these numbers, for example, let's take this 2, it can go from 0 to 255. And you can literally make billions upon billions of combinations with these numbers. Very simple concept to comprehend, and there's nothing too complicated about it. We'll later deal with the interfaces and other things, but for the moment, I just wanted to show you what an IP address is and how it is used, where it is assigned, and where you can find it. Anyway, there are 2 basic types of IP addresses: static and dynamic. Most private users have a dynamic IP address, while on the other hand, business users and servers mostly have static IP addresses. Static addresses, once assigned, do not change and facilitate a stable and a reliable way for other devices to communicate with the given server, on which various services are running. While dynamic IP addresses change every time a device connects to the internet or the local network, making it a lot more difficult for anyone to contact you simply because they won't know your address, as it changes quite often. Both dynamic and static IP addresses are provided by internet service providers. Okay, now that we have basic understanding of what IP addresses are, we can move on to ports. Computer ports are, in essence, docking points for all the information coming to our devices and all the packets that are being transmitted by them. They work in combination with IP addresses directing all outgoing and incoming packets to their proper places. Port ranges are defined and numbered. For example, there are most common ports that range between 0 and 1023, but the numbers go a lot higher than that, so no worries there. You have a pretty big range to work with. Here's a simple list of some well-known services and ports on which they run. So for example, you have FTP, which runs on port 21. FTP is a file transfer protocol, if you haven't heard about it. Also, you have HTTP, which we all use on pretty much daily basis, and HTTPS, same scenario there, except the information on port 443 over HTTPS is encrypted. And we have a DNS, which works on 53. So with the other ones, I'm sure that you've already heard about them or are familiar to an extent, but let me just quickly and briefly say what DNS does. So it basically resolves domain names to IP addresses and vice versa. So for example, google.com would be a domain name. I don't know the IP address of it, but here let me just find out. So we can just do ping google.com, and I'm going to interrupt the ping here. So you have it here. This is the IP address of google.com. Basically what DNS does is resolves this into this, and it can also be used for vice versa, pretty much. But enough about this. I will expand on this subject later, at the later stages of this, at some other point of time during these tutorials, when we actually go into the Wireshark, and once we do filters, once we actually start talking about filters and filtering protocols, etc., and so on. But for the time being, let's just keep our focus on the ports. Each individual port range has its particular purpose and will direct all packets in predefined directions. Here, allow me to do a bit of a demonstration here. So I'm just going to clear my screen, and I'm going to show you what ports are open on my computer, what ports am I listening on. So if I just do nmap localhost nmap host, there we go. Just disregard this upper part and concentrate on this one here. So you see, it says port, it says 111, state open, RPC bind, that's the service. 631 IPP. IPP is the Internet Printing Protocol. I should probably close that because I have no use of it. But here, I'm going to start my Apache web server, and immediately after that you will see that I will start listening on port 80. So service PD start, there we go, and I'm just going to do the nmap again. There we go. So now you can see that I am listening on port 80, it is open, and the service is HTTP. So all traffic coming to me on this port will be directed here. So you see I have localhost there, so HTTP localhost, and it throws me to this page, to the beginning page of the Apache server that is not configured. Anyway, that's just a bit of how traffic gets directed, and we will expand on ports a bit more later on as we dig into Wireshark, but for the moment I just wanted to give you some basic ideas so that you would have some sort of basic understanding upon which we will later be able to expand. And now we can deal with MAC addresses. MAC, it is spelled so, you see MAC, it stands for Media Access Control Address, and that is a burnt-in hardware address that uniquely identifies not your regular device in terms of networking, but rather instead your network card. Here's a short demonstration. So I'm just going to clear the screen out now. I'm going to do ifconfig, and you can see that there are various interfaces here, as before. So each one of these interfaces has its own MAC address. That is the MAC address of the network card to which the interface is configured. So you see this one is BC8556C6A505. My wired interface is 7486, and so on. So you see each one of these that is used to connect to the internet or something of a kind has its own MAC address, and it is uniquely identified so on the local network, not on the internet, but rather instead on the local network. Let me just round up this with protocols. Protocol in any system, in general, is just a set of predefined rules that determines how something should be done. In regard to computers, protocols are agreed upon or standardized ways of communication. To give you a real-life example or a comparison, just try to imagine two people trying to communicate. What would they need? Well, for starters, they would need to agree upon which language to use, and preferably when one talks, the other should listen. But as you know, this is commonly not the case. And that would be a protocol. Basically, they agree, okay, you will talk now, and I will listen. Then I will speak, and you will listen. We will use this language to communicate. And those are the predefined rules that make up a protocol. One of the most famous protocols today, one of the most used ones, would be a proper thing to say, is a TCP/IP. TCP stands for Transmission Control Protocol, and IP I have mentioned before, that is Internet Protocol. We will deal in great detail in later tutorials with TCP, UDP, and other protocols of similar kind. But for the moment, I just want to give you a hint of what is to come, and it would be unwise of me to deal with it now, as that is a subject for itself. Now that we are acquainted with some of the basic terms, you see how by just getting an IP address of a device, we more or less, by default, are given a sea of useful information. For example, from an IP address, you can conclude where the device is located physically. I mean, not only a country, figure out from which country is it coming from which city, from where in the city, etc. You have websites today that you can go on to, and you can type in an IP, and it will give you its location. It won't be as precise, but it will be good enough, trust me. And if we just figure out, if we do a scan of the system, and if we figure out which ports are open, on which ports is the system listening, we will be able to conclude in a good amount of cases what applications are running on the server or wherever. Anyway, next up we need to go over the OSI model briefly, and immediately after that we will actually start using Wireshark. We will first go through the installation, and then we're going to configure it, and then I'll show you the various options that it has, and most importantly of all, we need to go over traffic capturing and filtering. In any case, thank you for watching. I bid you farewell. Till next time. Now that we're acquainted with some of the basic terms,